Hello everyone. In this video we're going to be looking at homework problem number 5, and it asks, to what speed must an electron be accelerated for it to have a wavelength of 3 centimeters, which really is really big. So goal. The problem is pretty self-explanatory, but in problems like this, you can just kind of reword it to have it make more sense to you. So to me, to what speed must an electron be accelerated? I'm just going to say, what is the speed of an electron with a wavelength of 3 centimeters? So we need a way to relate speed and wavelength. In our equations, we know that wavelength equals Planck's constant divided by momentum. And we know that momentum has speed in it because momentum is just mass times velocity. So if we just plug in mv over here, we get wavelength equals Planck's constant over mass times velocity. And then algebraically, we can just solve for v, and then it becomes plug and chug. So we get, after we shift around, v equals Planck's constant divided by mass of an electron, because the problem asks about an electron, times wavelength. And then at this point, it's plug and chug. So we get Planck's constant divided by mass of an electron times the given wavelength in meters, so converting centimeter to meter, we get 0.03 meter. And plugging this into the calculator, we get 0.024 meters per second, which, when we think about it, is pretty reasonable. A wavelength of 3 centimeters is really, really long for an electron. So it would have to have a really slow speed. And we can see from the equation that we used, wavelength is proportional to 1 over v. So these are going to have an inverse relationship. The longer the wavelength, so the bigger wavelength, slower speed, which we see here. Really big wavelength, really slow speed. And then when you think about a really tiny wavelength, which has a lot of high energy, the velocity is going to get a lot faster. So in short, wavelength gets bigger, velocity gets smaller, which is what this answer supports.